Okay, so this last lesson in chapter 2 is weighted averages. I'm going to go over it just because I just want to show it to you, and you can always come back and watch this video. However, I'm not grading you on this lesson. We're moving right along. I don't want to confuse anybody, so it's here. There's not going to be a ton of questions about this stuff, though. It might be one or two on your EOC. But, there's other things I want to concentrate on. This, I don't want you to get wrapped up in this. So if it clicks for you, great. Here's the lesson. If it doesn't click and you are totally lost, just move on and don't worry about it. It's okay. There's no assignment on it this week. I do go over it a little bit in your chapter 2 review for your test, but it will not be on your test at all. All right? Okay, so for weighted averages, first we're going to start off with mixture problems, and then we're going to go to uniform motion. So mixture problems are problems with two or more parts that are combined into a whole. They involve weighted averages, and in a mixture problem, the weight is usually a price or a percent of something, and so it tells you what a weighted average is. I just want to jump right into this. So one way, if you're a visual learner like me, one way to separate out or organize your information is with a table, okay? So we've got a couple different variables, a few different variables. If you're mixing two things, like here it looks like we're making chocolate chip cookies or something. We're mixing chocolate chips. So we've got chocolate chips, we've got white chocolate chips, and we're mixing them together, right? For chocolate chips, they cost a certain amount, right? So you've got your number of pounds that you're buying of chocolate chips, and you've got how much it costs per pound, right? So you've got your weight, your number of pounds, your cost. So the total price of chocolate chips is multiply these two together, right? For white chocolate, that's different. So you've got a different number of pounds of white chocolate chips. They cost a different amount. Well, in this case, they're the same, but they could cost a different amount. So here's your total to figure out how many white chocolate chips you have. So if you were going to mix some of them together and you were going to say, all right, you've got some chocolate chips, some white chocolate chips, you know what they cost per pound, and you're going to buy 10 pounds total, and they're going to cost $6.75 on average per pound. How do you figure that out, right? Like what? What? I don't even know how to wrap my mind around that. So we're going to jump into this. So here with this table, and this is without the table. This is like just if you just saw this problem, right? Or if we just read this top part. So let's read it and see if we can kind of figure out the table, and then we'll use it down below. Cookies. Delectable Cookie Company sells chocolate chip cookies for $6.95 per pound and white chocolate cookies for $5.95 a pound. Oh, I was reading that the same. How many pounds of chocolate chip cookies should be mixed with 4 pounds of white chocolate cookies to obtain a mixture that sells for $6.75 per pound? So chocolate chip cookies cost $1 more per pound than white chocolate. But if you buy a little bit of each and you mix them together, then they cost $6.75 per pound total. How do we figure out how many pounds of chocolate chips we need, right? So that's where they made the table. You would make it, right? The problem doesn't necessarily make it. You would need to know how to organize it. So we've got two things here. We've got the cost, money, and we've got the weight, number of pounds, right? So they've got number of pounds column, the price column. Okay, so for chocolate chip cookies, again, we've got number of pounds of chocolate chip cookies, price per pound, so the total would be the price times the number of pounds. Same with white chocolate. We know, it tells us we have 4 pounds of white chocolate. We know it's $5.95 per pound, so to figure out the total, we would just multiply that together. We're going to put 4 times $5.95 is $23.80. Right? We don't know what this top amount is because we don't know how many pounds of chocolate chip cookies we bought. But we know we spent this much total on 4 pounds of white chocolate. So if we mix them together, we've got number of pounds we bought of chocolate, number of pounds of white chocolate. That's this. We've got price per pound. We know chocolate's this, white chocolate's this. And when we mix them together, it comes out to about this. And the total would be $6.75 times however many we bought of each, right? It would average out. So how would we set that up in an equation? They did it here for us. You would do $6.95 times the number of pounds you bought plus $5.95 times the number of pounds you bought of that. And that should be equal to, if you add that together, that should be equal to the average price per pound and the total amount of pounds you bought. So you add these two together, set them equal to this. That's what they did over here. Okay, so then when we start solving, we already said this was 2380. So 695W plus 2380 equals 675W plus 675 times 4 is $26. And when did they start solving this? Down here. Oh, 27. What did I do wrong? 675 times 4. 6.75 times 4. 27, yeah, sorry, my fault. Okay, so once we get this right here, we're going to catch up at this line. So they showed you how they solved it here. We got 695W. They multiplied this together, and then they used distributive here. Then we have to start solving. We've got W's on both sides. 675 is smaller than 695. So they subtracted the 675 over here, and that canceled. They did the same here. And when you subtract 6.95 minus 6.75, you get 0.2 W. We still have this 2380, and over here we still have the 27. Okay, so now we're solving for W. That's our weight of chocolate chips that we bought, chocolate chip cookies. So they go ahead and subtract 2380 from both sides of the equal sign. Over here it cancels, so we're left with 0.2 W. 27 minus 2380 is 320. And if you divide both sides by 0.2 to get W alone, you get W equals 16. So that means, up here in our table, 16 pounds of chocolate chip cookies at $6.95 a pound, plus 4 pounds of white chocolate cookies at $5.95 a pound, added up to an average of $6.75 a pound, and that's when we bought 20 pounds of cookies. Most of that was chocolate chip. 16 of the 20 pounds were chocolate chip. Only 4 of the 20 pounds were white chocolate, which is why this price is closer to chocolate chip than white chocolate, right? But that's a mixture problem. So it stinks, right? It's like super complicated. It is helpful to know how to mix stuff like that, but we're not going to stress out over it. Okay, we have 4 problems on this page, and then we flip it over and do our motion stuff. So here, how many grams of sugar must be added to 60 grams of a solution that's only 32% sugar to obtain a solution that's 50% sugar? Okay, so how much grams of sugar? Grams of sugar is 100% sugar. And the number of grams of sugar is, we're just going to say, is G. That's what we're looking for. We don't know how many, right? So 100% times however many grams of sugar we buy, plus, we're going to add it with 60 grams of a 32% solution. So 32% times 60. And that's going to give us a solution that's 50% sugar. So 50% times, and I have to add up how many grams I had total. So number of grams of sugar plus number of grams of the solution, watered down solution, which was 60. Okay, so this is how we would set this up. Now, the next thing you need to know is that whenever you have a percentage in a problem, you cannot leave it as a percentage. You have to change it to a decimal, right? A percentage as a number is what you get after you divide the percent by 100, because it's the number out of 100. So here, 100 divided by 100 is 1, so we'd have 1 gram of sugar, plus 32 divided by 100 is 0.32 times 60, and then 50 divided by 100 is 0.5, 0.50, and then we're multiplying that by this much. So how many grams of 100% sugar plus 60 grams of 32% sugar will give us a total amount, whatever the weight I had was total, right? This grams plus this grams. That's 50% sugar. Okay, that's just like the red food coloring. Full red food coloring plus some watered down red food coloring gives us how much? Half red, right? Full red plus just a little bit red gives us half red. How much of it? So we're solving for G here once we set the problem up. 0.32 times 60 equals 19.2. I'm running out of room here. Let's see if I have a blank sheet of paper somewhere to write on. I did have it up. Here we go. So I've got G plus 0.32 times 60 equals 0.5 times G plus 60. Okay, this is what we're solving. So 0.32 times 60 is 19.2. G plus 19.2 equals, and then if I go ahead and distribute, 0.5 G plus 0.5 times 60 is 30. Now I got to get rid of my smallest G out of 0.5 and 1. 0.5 is the smallest. Minus 0.5 G. These go away. 1 minus 0.5, you can use your calculator. It's just 0.5. $1 minus 50 cents leaves us with 50 cents. Plus 19.2 equals 30. Then I got to subtract 19.2 from both sides. This is why it's important you know how to solve 1 and 2 step and multi-step equations, or equations when you have the variable on both sides. Because then you can start applying it to more complex problems, right? So I've got 0.5 G equals 30 minus 19.2. And then lastly, I need to divide by 0.5 to get G alone. G equals 21.6. About 21.6 grams. And did it tell us to round to the nearest whole number? No, didn't say anything. It just says how many grams of 100% sugar must be added to 60 grams of 32% sugar to obtain a solution that's only half sugar, right? So we need about 21.6 grams of full sugar. 21.6 grams. That's what I'm telling you. If you followed that, fantastic. It's actually not super terrible for some of these, but if you're confused, do not worry about it. All right, number 2, nuts. The Quick Mart has 2 kinds of nuts. Pecans or pecans or whatever you call them. Pecans sell for $1.55 per pound, and walnuts sell for $1.95 per pound. How many pounds of walnuts must be added to 15 pounds of pecans to make a mixture that sells for $1.75 per pound? Right? So think of our little table. We have number of pounds. I could have done the table the last problem and I didn't do it. We have price. And then we're going to put them together, right? And we've got pecans, we've got walnuts, and we've got our mix. So here's our table, right? Pecans, that's what we're solving for. How many pounds of pecans? We don't know, so I'll make that P. But I do know that pecans sell for $1.55 per pound, 1.55. So the total I'm going to pay for pecans is 155 times P. Walnuts sell for $1.95 per pound. And how many walnuts? Oh, sorry, I do know pecans. How many walnuts will be added to 15 pounds of pecans? So this is going to be 15. Sorry, I didn't read the problem. This is 195W. And our mix here is, we know, $1.75 per pound. Pounds total will be 15 plus W. And just like up here, we multiply these two together to get the total, multiply to get the total, multiply to get the total. 15 plus W. So we're going to add these two columns together and set it equal to this bottom column, right? So 15 pounds of pecans, which are $1.55 per pound, times 15 pounds, plus how many pounds of walnuts, we don't know yet, that's what we're solving for, which are $1.95 per pound, gives us walnuts plus pecans, the pounds that we bought, right? I don't know how many that is total, times, and then it says it has to be $1.75 per pound for the whole thing. So we've got just pecans, just walnuts. We're going to add them together. When we add them together, the weight, the number of pounds we bought, we're going to add those together. And the price per pound will average out to this depending on how many pounds we buy of each kind, right? So now we're just solving for W. Okay, so I can start using my calculator. 15 times 1.55 equals 23.25 plus $1.95 W equals $1.75 times 15. 26.25 plus $1.75 times W. Okay, so far so good. Now I've got W's on both sides of my equal sign, so I got to get rid of the smallest one, minus 1.75 W. On both sides of my equal sign, on the right side they cancel, so I'm left with 23.25 plus 0.2 W equals 26.25. And I'm trying to solve for W, which is the number of pounds of walnuts I need to buy, right? Okay, so here I need to get rid of 23.25 minus 23.25. 0.2 W equals 26 minus 23 is 3. And then I divide by 0.2. These go away. W equals 15. So I got to buy 15 pounds of walnuts. 15 pounds of walnuts. I already bought 15 pounds of pecans at $1.55 each. So if I buy the same amount of walnuts, 15 pounds, at $1.95 each, then the total should average together to $1.75 per pound times 30 pounds total. Right? Makes sense. So we'll say for walnuts, 15 pounds. Number 3, investment. Alice Gleason invested a portion of $32,000 at 9% interest and the rest of that at 11% interest. How much did she invest at each rate if her total income from both investments was $3,200? That's what I'm talking about. It seems complicated, right? All right, so she invested some of this at 9%. So I don't know how much she invested. I'm going to change the percent to a decimal. 0.09, not 0.9. 0.9 would be 90%. It's 0.09. So 0.09 times an amount, I don't know what the amount is, plus she invested the rest of the money at 11%. So 11% that way. And the rest of it would be the entire $32,000 minus whatever she invested up here. Leaves me the rest of it, right? So out of $32,000, she invested some of it at 9%, and she invested the rest of it at 11%. So total together, those investments gave her $3,200 at the end. So I have to figure out how much did she invest at the 9% and how much did she invest at the 11%. Okay, once you know how to set it up, it's easy to solve for x, but the setting up part is what's hard. All right, so 0.09x plus, and then I distribute this guy, right? So 0.11 times 32,000 is 3,520. And then carry down my minus sign, 0.11x equals 3,200. Now I've only got one variable here, so I can go ahead and combine these, right? 0.09 minus 0.11, 0.02, yeah. Negative 0.02x, when I combine my x's, I still have this plus 3,520. And then the other side of the equal sign stays the same. Now I got to solve for x. So I'm going to start getting rid of stuff around it. These cancel. So I've got negative 0.02x equals 32 minus 3520 is negative 320. And then I have to divide by, I want to solve for x, so I got to get rid of negative 0.02. Right, so over here, the negative 0.02's cancel, and I'm left with x equals negative 320 divided by negative 0.02 equals 16, 1, 2, 3. When you divide by less than 1, you're actually kind of multiplying. I know that sounds funny, but anytime you divide by a fraction or divide by a decimal, your number's going to go up. So here, x is 16,000. Well, what was x again? X was the amount that I invested at 0.9%, or whoever invested at 0.9%, or not 0.9, at 9%. So they invested 16,000 at 9%, and whatever was left over of the 32,000, they invested at 11%. So this much, we'll say 9% was 16,000. And 11% was, well, together it added up to, it was 32 grand total. So 32,000 minus 16,000 equals 16,000, right? So they invested 16,000 at 9%, 16,000 at 11%. All right, and then for milk. Whole milk is 4% butterfat. How much skim milk with 0% butterfat should be added to 32 ounces of whole milk to obtain a mixture that's 2.5% butterfat? Okay, so we're going to multiply the percent times how much of it there is, right? So whole milk is 4% butterfat. We have 32 ounces of whole milk. So 32 ounces of whole milk, which is how much butterfat? 0.04%. I gotta change my percent to a decimal. Plus, how many ounces, I don't know, x, times skim milk, which is 0% butterfat. So whole milk, 32 ounces of whole milk, plus how many ounces of skim milk is gonna give me a mixture that's 2.5% butterfat. So that's 0.025, divide 2.5 by 100, 0.025. And then the amount is 32 plus x. So you're multiplying the amount times the butterfat, the amount times the butterfat, add those together. That gives us the average amount times the butterfat, right? Each one, and then average, adding them together. Okay, so here 32 times 0.04, 1.28. Plus, and x times 0 is just 0. They cancel out, right? Now, it seems funny, like, okay, well, duh, then this should be easy to solve. It just cancels out. But it doesn't cancel out over here. We do have an x over here, so we do need it. Even though it's 0% butterfat, we still are going to have a number of ounces of skim milk. So we got to solve for that. So 0.025 times 32 is 0.8, because we're distributing here. So 0.8 plus 0.025 times x. So here's our equation. Now I got to get rid of my smallest x. Well, I only have one x, right? So I got 1.28 equals 0.8 plus 0.025x. This goes away. This is my only x, so I want to get it by itself. So I need to get rid of 0.8. These go away. 1.28 minus 0.8 equals 0.48. 0.48 equals this, 0.025x. And the last thing I got to do here is divide. So I'm going to divide this side by 0.025. Divide this side by 0.025. These cancel. So I'm going to have x equals 0.48 divided by 0.025 equals 19.2. So how many ounces of skim milk did I need to mix with 32 ounces of whole milk to get a 2.5% mixture? 19.2%. Even though it seems super complicated when you try and understand it and wrap your mind around it logically, we've pretty much been setting everything up the same. So if you can see the consistencies in how we set it up, that should help. All right, last page. I don't even know if I'm going to do all of them. Sorry. Again, you do not have to have all this. It's helpful, but you don't have to have it. All right, weighted averages. We're doing uniform motion problems. Same exact concept, but instead of amounts and prices in pounds, now we're talking about speed. Okay, so motion problems are another application of weighted averages. Uniform motion problems are problems where an object moves at a certain speed, and use the formula distance equals rate times time to solve these problems. Distance is d, rate is r, and t is time. Tells us right there. All right, so we're just going to jump right into these examples here. If you want to read through the study guide, you can, but here we go. All right, Mr. Anders and Miss Rich each left and drove home from a business meeting, so they started at the same point, at the same time. Mr. Anders traveled east at 100 kilometers per hour, and Miss Rich traveled west at 80 kilometers per hour. In how many hours were they 100 kilometers apart? Okay, so they start here. One of them goes this way. One of them goes this way, right? The one going east to the right goes 100 kilometers per hour. The one going west or left goes 80 kilometers per hour. So how long until their total distance apart is 100 kilometers, right? If he's going this way and she's going this way, how long until they've gone 100 kilometers apart from each other? How do I set that up? Well, remember, distance equals rate times time. And if the distance is 100, the total distance they've gone, I'm adding how far he's gone plus how far she's gone, and that gives me the total 100, right? So I'm adding his distance plus her distance, and that gives me the 100. Well, I don't know distance equals rate times time. 100 equals, I don't know what his total distance is and her total distance is. All I know is their rate, right? Distance equals rate times time. So the whole thing, 100 equals, I'm adding the two of theirs together. Each of theirs, distance equals rate times time. I don't know their distance, but I know their rate. His is 100 kilometers per hour, and hers is 80 kilometers per hour. And distance equals rate times time. That's what I'm looking for. How many hours? After how many hours are they 100 kilometers apart? So their total distance is 100. That's made up of his distance plus her distance. And distance equals rate times time. His rate is 100 times however many hours he's gone. Plus her rate is 100 times however many hours she's gone. So then I can solve that. 100 equals, combine like terms, 180h. To get h alone, I'm going to divide both sides times 180. So h equals 100 divided by 180. And I can start simplifying that. I could change it to a decimal, but there's no decimals here. So I don't want decimals if there's none in the problem. So I'm going to divide the top and the bottom both by 20. So 100 divided by 20 is 5. 180 divided by 20 is 9. So they went 5/9 of an hour. They didn't even go a total hour. Right? How many hours until they're 100 kilometers apart? Well, if he's driving 100 kilometers by himself in 1 hour, and she's going the opposite direction and she's going 80, it's going to take less than an hour, right? It would be an hour just for him to go one direction by himself. She's already going the other direction. How long until they're 100 apart? Definitely less than an hour. So 5/9 of an hour. Number 2, airplanes. An airplane flies 750 miles due west in an hour and a half, and then it turns and flies 750 miles due south in 2 hours. What's the average speed of the airplane? This is actually easy because we're just averaging it out, right? What was the total amount they went? It went 750 in one direction plus 750 in the other direction, right? What was the total amount of time they've been flying? Well, hour and a half in one direction plus 2 hours in the other direction. That's 1,500 miles total in 3.5 hours. So what's their average speed? Just divide the 1,500 they've gone by 3.5. And I get 428.5714, blah, blah, blah. And it says, what's the average speed? It doesn't ask us to round. I'm going to round to the nearest tenth, so that's 428.9. And they were traveling in miles per hour, so that's mph. And if you're like 420 miles per hour, is that even right? Well, think about it. If they went 750 miles in 2 hours one direction, what's that per hour? 750 divided by, that's 375 miles an hour. And here they're going faster than that because they went 750 miles in less time than that. So they were going even faster than 375 miles an hour here. So when you average the two together, you get about 429 almost miles per hour. That's their average speed. Okay, number 3, track. A sprinter runs 100 meters in 15 seconds. Oh, sprinter A. While sprinter B starts 1.5 seconds later, but he still runs 100 meters in 14 seconds. If each of them runs at a constant rate, meaning they don't speed up or slow down, who is further in 10 seconds after the start of the race? Explain. Well, first let's find their average speeds, right? So sprinter A sprints 100 meters in 15 seconds. So that's his rate. Sprinter B runs 100 meters in 14 seconds, right? So it wants to know 10 seconds after the race starts, who is further along. Well, if this is his rate, sprinter A, he starts off the race, right? After 10 seconds, how far has he gone? Well, 100 divided by 15 times 10 equals about 66.6 repeating. 66 point, we'll round it to a 7 meters. Right? After the start of the race, that's how far he's gone. After the start of the race, runner B doesn't start right away. So the gun or the whistle blows or whatever happens, the race starts, sprinter A starts. Maybe he's like further out. You know how they're always, well, no, that wouldn't, then they'd start at the same time. You know how like when you're running a track and the inside tracks are shorter than the outside, so people on the outside always start ahead of people on the inside? I guess it's that kind of deal, right? So sprinter B, they don't let him start right away. So the race starts, but he doesn't start running until a second and a half after sprinter A. So he gets a second and a half less than the full race. So the whistle sounds or whatever happens, a second and a half later, sprinter B starts running. So after 10 seconds of the race, 10 seconds after the race starts, yeah, he didn't start when the race started, but 10 seconds after the race started, when the whistle blew, who was further along? Well, he only ran for 8.5 seconds, even though he runs faster. So 100 divided by 14 times 8.5, 60.7 meters. 60.7 meters. So it said, who is further in 10 seconds after the start of the race? Explain. Sprinter A. I pointed the arrow the wrong way. Sprinter A is further ahead by 6 meters. Sprinter B started late. Right? That's all we have to say. Really explain just means show your work. So who was ahead? The guy that started the whole race, right? Now, sprinter B is faster, so maybe in another 10 seconds or another 20 or 30 seconds, sprinter B will pass sprinter A. But just right 10 seconds after they've started, he hasn't caught up yet. He's not quite that fast, so sprinter A is still ahead. Takes him a second longer to run 100 meters than it does sprinter B, but in 10 seconds, he hasn't made up that difference. All right, number 4. trains. An express train travels 90 kilometers an hour from Smallville to Megatown. A local train takes 2.5 hours longer to travel the same distance, and they're going 50 kilometers an hour with the same distance. How far apart are Smallville and Megatown? So this is like a two-part question. First thing I know is distance equals rate times time, right? And if both cars are going the same distance, one's going a lot faster than the other, but the actual distance they're traveling is the same, right? So for one, for the express train, I can say it's 90 kilometers an hour times however many hours he goes. For the city train, he's going 50 kilometers an hour plus another 2.5 hours. Takes him 2.5 hours longer to go his rate, right? But they're both going the same distance. So I can actually set them equal to each other because the total distance that they're both going is the same. So I'm going to set 90h equal to 50 times h.25, h plus 2.5, and then solve. So I got 90h equals 50h plus 50 times 2.5 is 125, I think. 50 times, whoops. So we got 125. And I'm solving for h. Now, notice h is not the distance. The question is how far apart are Smallville and Megatown, the distance they're both traveling. So right now I'm solving for time. Once I know time, I can use it to find distance, but right now I'm solving for time. So I subtract 50h from both sides of my equal sign, and I get 40h equals 125. So when I solve for h, I divide both sides of my equal sign by 40, and I get h equals 3.125. So that's how many hours it takes them to go the same distance, right? Now, this guy, the fast guy, goes a lot faster. The slow guy goes a lot slower. But total, this is how many hours it takes for both trains to arrive after the distance they met. This guy will get there first, but this is the total amount of time it'll take both of them. So now I can plug h in to my distance equals rate times time guy, right? And I can solve for the distance. So now I can just pick one, either 90 times h or 50 times h plus 0.25 or h plus 2.5. I can pick one and plug in the hours here. So distance equals 90 times 3.125, and 90 times 3.125 equals 281.25 miles or kilometers. So that's the total distance it is from Smallville to Megatown, 281.25. All right, we're almost done. Almost done. 5, cycling. 2 cyclists began traveling in the same direction on the same bike path. One travels at 15 miles per hour and the other travels at 12 miles per hour. When will the cyclists be 10 miles apart? Okay, so they're going the same direction. They both start off. We've all got that extra friend, right? That friend that's so extra. I was trying to be cool and it came out stupid. We've got that friend that just has to go way ahead of you. They can't walk with you or bike with you. They got to go way ahead, right? We've all got that friend. So they both start out and one goes faster than the other. So every hour they get 3 miles apart because one's going 12 miles an hour, the other's going 15 miles an hour. So after how many hours will they be 10 miles apart? 15 minus 12 equals 3 per hour. They're 3 miles apart per hour. So when will they be 10 miles apart? 10 divided by 3 equals 3 1/3 hours. After 3 1/3 hours, they will be 10 miles apart because each hour they get 3 miles apart. So 3 plus 3 plus 3 plus 1/3 gives us 10 miles total. 3 1/3 hours. And number 6, 2 trains leave Chicago, one traveling east at 30 miles an hour and one traveling west at 40 miles an hour. When will the train be 210 miles apart? So they're going in opposite directions, right? This was like that very, very number one. Mr. Anders and Miss Rich left home. One went 80 kilometers an hour, one went 100. We're solving this the same way. So they both start together. One goes this direction, one goes that direction. One's traveling faster than the other. The one going east is going 30 miles per hour. The one going west is going 40 miles per hour. After how long will they be 210 miles apart? So we're going to add this guy plus this guy, and that's going to total 210. So 210 equals 30 times however many hours they're traveling plus 40 times however many hours they're traveling. And then we can solve for the number of hours. 210 equals 70h. Divide both sides by 70. 3 hours equals 3. It's going to take them 3 hours to get 210 miles apart from each other, right? 3 hours. If one of them's going 30 miles an hour, one of them's going 40 miles an hour, 30 times 3 is 90 miles. 40 times 3 is 120 miles. So the slow guy's only gone 90 miles in 3 hours, one direction. The fast guy's gone 120 miles in one direction, but total, that's 210 miles that they're apart after 3 hours. Makes sense? All right, let me know if you guys have questions, but like I said over and over, do not stress over this lesson. It is not a big deal. It's not on your test for this week, and you do not have homework on it.